Hello, I'm Rebecca the Maths Lady and welcome to this video which is all about the sizes of angles. In this video I'm going to teach you how we teach children in ways that mean that they'll be able to deeply understand, name, measure and draw angles of different sizes. We're going to start with right angles, look at angles that are more or less than certain numbers of right angles and then work on through degree measurements. And we're going to always focus on the importance of children estimating the size of an angle before they measure it. There's no particular videos you need to have seen before this one, but the general background is that children should have a sense of what a half turn and a quarter turn is. They should understand about turning right and turning left, and they should have a sense of what clockwise and anti-clockwise are. So it's worth checking those things before you start. If you have children who have a particularly poor understanding of their own position in space, then it's worth just checking out that their coordination is as it should be. And here's a link to a video I recorded with Charlotte Davies, who's a specialist in this area, which explores those issues in more depth and gives you some practical strategies for assessing children and intervening if you're finding that they're struggling. Right, let's get started. So children should already have an understanding of what a quarter turn is. Now a turn is a movement, and one of the mistakes teachers make when they're teaching angle is that they don't realise that there are two ways of understanding angle. There is angle as turn when you're physically moving, and there's the angle that is the vertex, the corner of a shape. So for example, the size of the angle of this regular pentagon. Now you can marry up the two. If you imagine that you're facing this way and then you turn, so you're facing that way, then you've turned through the angle which is the corner of the shape. But before they come to angle age 7 to 11, they probably haven't thought about angle relating to corners yet. They've thought about it being physical turning motions, and it's important that you slow down and zone in on the fact that they may find this idea of angle confusing. The next thing is to relate the idea of a quarter turn to the name of a right angle, which is something that children may not have come across. They need the chance to discover that a quarter turn is the corner of a square and link those two ideas. You could deal with that by tearing the four corners off a square or a rectangle and putting them together, points inwards, so you can see that they're a full turn. Or you could get children to stand on the corner of a square and point along one side and physically turn and point along the other side and link that idea that they've turned through a quarter turn to that quarter turn being the corner of a square and a right angle being a quarter turn. There's some vocabulary that comes in at this stage, the idea of horizontal lines. Horizontal lines are like the horizon, and vertical lines are like a vertical cliff face. It just drops straight down, or a vertical slide that you sometimes get in play centres where it's vertical at first. So children need to know horizontal and vertical. They also need to know parallel and perpendicular. And they need to know that perpendicular lines cross at right angles, and that perpendicular lines are not always vertical and horizontal. They might be at other angles. So it's great to get them doing arm actions for horizontal, vertical, parallel and perpendicular, with both the parallel and the perpendicular moving so they see them in different ways. And you can extend that work on right angles out to half turns and straight lines and 3/4 turns and 3 right angles. And you may want to consolidate that with a Bbot or a Roma or a programmable device that's going to follow those instructions. The next stage is to consider angles that are more or less than a right angle. So we can give children a page of shapes and ask them to find some angles that are more than a right angle and some that are less. And the best way to do that is to give them a right angle that they can put against corners like that, so they can actually compare it and see that that corner there is larger than a right angle, but this one here at the base of this kite is smaller than a right angle, and so on. And then, of course, we introduce the vocabulary for that, an angle that's smaller than a right angle. Well, small things are usually cute, so it's a acute angle or an acute angle. And an angle that's more than a right angle is a bit large, a bit awkward, that's obtuse. And then, of course, you can introduce the language of the angles that are bigger than a straight line. And you do that by tapping the reflexes of their knees and showing the angle above the knee going round the corner and how it changes as your leg moves when you tap then reflex below their knee. But all those angles from the horizontal thigh downwards are reflex angles. Sorry, I'm not quite flexible enough to demonstrate that on camera. And at this stage, I'm just going to show you a highly technical bit of apparatus that we use for teaching angles. 2 circles of paper. And of course, if you haven't got any cuts, you can set some of your children who've finished a task early to use pairs of compasses to make circles and cut them out for the whole class. That'll keep them busy. So with each of these circles, fold it in half, but don't crease it. Fold it into quarters, but don't crease it, but find the point. And then open that up, and then crease it from the point along one radius. There, open that up again, and then cut it along one radius. And then I'm just going to do the same with the other circle. So we have 2 circles like these, and then we just slot them together like this. And then we can show angles of different sizes just by rotating them. So you can ask children to show you an acute angle with the blue circle, and another acute angle, and another one, and so on, and a right angle, and a half turn, obtuse angles, reflex angles. Really nice to do. And of course you can see what every child is thinking. But that language isn't very accurate. How are we going to compare angles when they're both acute? How can we measure them? And of course the answer is with degrees. And we're going to introduce children to the idea that a full turn is cut into 360 degrees, or a half turn is cut into 180 degrees. Why 360? Well, in preparing this video I was looking for an explanation, and the nicest one I found is that the Sumerians were mapping the movements of the stars, and of course they complete a full rotation every year as the Earth revolves around the sun. And in their estimations there were 360 days in a year, so 1 degree was for each day's movement of the stars in the sky. And this definition is linked to the Sumerian culture about 2400 BC. It may or may not be true, but I like it because it makes a little bit of sense, and it links nicely to the idea that there are 365 days in a year, so they weren't far off, which is pretty good given the resources and the technology that they had at that time. So we want children to deeply get to know the idea of there being 360 degrees in a full turn, 180 in a straight line, and 90 in a right angle. And they need to make those calculations and those links many times. It's worth drilling them for rote learning after a while. And then we can deeply develop their sense of angle. If they all know that that's 90 degrees on the blue, can they each estimate 60 degrees? Can they estimate 10 degrees? Could they estimate 150 degrees? Lots of great work going on there. It's really important to do that at this stage before they begin to measure angles. They need to get a deep sense of visualizing angles approximately. Otherwise they're going to go wrong because of the way in which protractors work, where they have 2 sets of numbers. So once they've done a bit of that, then we can take them on to measuring some angles. So let's look at this parallelogram. First of all, can they estimate the size of that angle? And we want them to notice that it's less than 90 degrees. Then, of course, we put the protractor on with the crosshair at the corner and the 0 line along one edge, like that. And then they are counting round from 0. And that's going to be about 82 or 83 degrees. We know that the other numbers, 90 to 100, cannot be relevant because we know that angle is less than 90 degrees, and we can check it with our square corner. Here's my handy square. If we just put that on, it's clearly not as big as 90 degrees, and that kind of checking needs to go on again and again. So children need to do lots of measuring angle, and then they're going to need to draw angles. So they'll need to learn to draw a straight line, put the crosshair of the protractor on one end of that straight line, and count round from 0 to the number of degrees they want, put a dot, and join all that up with a straight line with their ruler, and then sense check what they've done. Have they drawn an angle that's acute if it needs to be acute, is obtuse if it needs to be obtuse? They should always sense check their angle measurement and their angle drawing, because it is so easy to go wrong. It's great to draw rough sketches of shapes with some angles written on, and children have to draw them accurately. You can give them perfect shapes to one member of a pair, and that person has to describe the shape to their partner who can't see them draw anything or move their hands. They've just got to describe it precisely, and the partner has to draw it. That's an excellent exercise. And you may be able to embed that into art or design, and it's great if you can. There are some more opportunities to practice that art of precise drawing in the next video on angle rules, and also in the video on three-dimensional shape, which is coming, where children will need to draw accurate nets for making three-dimensional shapes, and that will require some accurate drawing. Sometimes when you're teaching maths, it's nice to use some common errors teaching. So you might want to show them a question that a child has got wrong because they've read the protractor the wrong way and haven't sense-checked their answer. And if your children that you're teaching are instantly shouting at you that it's wrong, then they've got it. And if they're not seeing that quickly, then you need to do some more work on that idea that they need to sense check their answers and have a deep sense of what is more or less than a right angle. And just to complete this part of the video, I'm going to remind you that at the start I explained that angle is both about physical turning and about the corners of shapes. Now, we've been focusing on the corners of shapes, but it is a great idea to give children physical activities where they're walking in a line and then they have to turn through a certain number of degrees, clockwise or anti-clockwise. And when you're giving each other these instructions, you can see whether they've deeply internalized their understanding of angle or not. You could set up an activity where you've got a shape set out with masking tape on the floor and one child's blindfold and another child is trying to give them instructions, and they're only allowed to say forward so much or clockwise turn such and such an angle, and so on. So in summary, I've explained how angle is both about physical turn and about the corners of shapes, and how we need to marry those two ideas up. How we start with an understanding of quarter turns, to which we apply the vocabulary of right angles, which we expand into horizontal and vertical, perpendicular and parallel. How we look at angles that are smaller and larger than right angles and half turns, and develop the angle of acute, obtuse and reflex. And then how we learn to measure and draw angles accurately. I hope you found this video useful. If you have, if you're able to give us a subscribe or a like or a comment, or share this video with people that might find it useful, that would be fabulous. Comments, criticisms, suggestions are always hugely warmly welcome in the comments on the video. I'll be back again soon with the next video, which is all about angle rules, where we'll be looking at opposite angles on crossed lines and angles in triangles, quadrilaterals and regular polygons. Hope to see you soon. Bye for now.